warm up. Fractions, okay? I get a lot of questions about fractions all the time. So let's talk about, once again, multiplying a whole number by a fraction, multiplying a fraction by a fraction. So when we multiply a whole number by a fraction, we want to make the whole number a fraction by doing what? Putting a 1 underneath it, right? So we put a 1 underneath it, and we can do one of two things. We can multiply straight across. So if I multiply straight across, I get 36 over 4, which equals 9, right? Make sure you always simplify. Or my other option is to cross cancel first and then multiply. So I cross cancel diagonally if they have common factors. I see that 12 I can divide by 4, right? So 4 goes into 12 3 times. And then I end up with 3 times 3, which equals 9. Same answer, right? Different ways of doing it. I do the cross canceling because it definitely keeps all my numbers smaller. Okay. Number 2, fraction times a fraction, multiply straight across or cancel diagonally. Okay, so if I multiply straight across, I get 18 over 24, and then I have to reduce that, right? If I cross cancel, 2 goes into 8 how many times? 4 times. What else can I cross cancel? 3 goes into 9 how many times? 3. There's nothing left to multiply, so I get 3/4. Okay. If I had multiplied straight across, I get 18 over 24. I have to divide them both by 6, and we get 3/4. Okay. So number 3, we'll put a 1 underneath the 24. 2 goes into 24 how many times? 12, and 12 times 5 is 60. Okay. Here's where I really like the cross multiplication, because 24 times 5 in my head, I don't necessarily know, right? And so making that 12 times 5, I know that a little bit better, okay? All right, so we're going to go over questions of homework. I know we need to go over 7 and 11. What other problems would you like me to do? Morelia? Number 10. What else? 5? 9? 12. 6. The majority of them. Okay, so let's look at numbers 5. 5 is negative 12 less than 5 halves y minus 2 less than negative 2. So we treat this as one equation. Whatever I do to the middle, I'm going to do to the right and the left. So what am I going to do first? I'm going to add 2. So I get negative 10 is less than 5 halves y is less than 0. And again, there's that fractional coefficient. We multiply by the reciprocal, 2 over 5. So we're going to multiply by 2 over 5. Multiply by 2 over 5, and multiply by 2 over 5. Now 0 times anything is just 0. Don't forget that. Okay. And these cancel. I get 1 over 1, which is just y. And then I get 5 goes into 10 2 times, right? And it's negative 10, so negative 2 times 2 is negative 4. So the negative 2 times the 2 is 4.
The way I did it, I didn't do 2 over 5, I just multiplied it by 2. Will I get a...
And then divided by 5?
Yeah.
Yeah. It's the same thing, you're just doing it in more steps, right? When I multiply by 2/5, I'm multiplying by 2 and then dividing by 5. Okay, so you get the same answer, and that's fine. So we'll draw this on a number line. Negative 4 and 0, open circles for both, greater than negative 4 less than 0. Okay. Number 6. So this problem has decimals in it. When the problem has decimals in it, we want to give our answers as decimals. If the problem has fractions in it, we'll give the answer as fractions if they are not whole numbers. So we're going to start by doing what on this problem? Number 6. What do we have in the middle? Negative 7.2 plus 3x. So we're going to add 7.2. And we get 0.9, right? Is less than or equal to negative 3x. Is less than 10.2. And then we'll divide everything by negative 3. What has to happen if I divide by a negative? My sign has to flip. Good. So it becomes greater than or equal to x, greater than, let's do a little long division here. 3 goes into 10.2. Bring up the decimal point. 3 goes into 10 3 times. 3 times 3 is 9. Subtract. Bring down the 2. 3 goes into 12 4 times. So we get negative 3.4. Okay, you will not have calculators on any test or quiz for most of the semester. So you have to be able to do these things by hand. Okay, so I suggest practicing without a calculator when you do your homework.
I was working on the homework with someone from Mrs. class, and the answer for 6, the signs weren't flipped. So.
Well, I have to flip it back now because 3.4, negative 3.4 is smaller than 3. So I need to flip it back around because I'm not supposed to put greater than signs in my and notation. So when I flip it back around, I get negative 3.4 is less than x is less than or equal to negative 3. Okay, we always have to write it with the small number first, smallest number first, and less than signs. Okay. And I have an open circle for 3.4 and a closed circle for negative 3, and shaded in between. Questions?
Would I get marked wrong if I put the negative 3 first?
This one? Yes. Okay, we have to know correct notation. Okay, so you always have to put the smaller number first and turn the signs around. Okay. So yes, you need to make sure you change this because this is incorrect notation. All right, number 7. 7 minus 3x minus 8 is greater than or equal to 6x. So on this one, I'm going to start by distributing the negative sign to the whole parentheses. I get 7 minus 3x plus 8 is greater than or equal to 6x. I'll write the other equation later. Or x plus 5 over 4 greater than or equal to 2/3. So we'll solve this one here. I can combine like terms. 7 plus 8 is 15. And then we're going to add 3x. And 15 is greater than or equal to 9x. Divide by 9. And I need to write it as a fraction. X, I'm going to write the x first. It's less than or equal to. So when I write the x first, I have to flip the inequality. It should always be opening to the same thing. So here, it's opening up. The opening is to the 15, and the point is to the x. So when I write the x on the other side, my point needs to be to the x, and my opening needs to be to the number. And then I reduce that fraction. I can divide them both by 3. So I get 5/3. Okay, now this problem didn't start with fractions or decimals, so the default is a fraction. I don't need to make it a mixed number, but I need to have it as a reduced improper fraction. Okay, that's the default. Because a lot of times you need a calculator to turn it into a decimal, and we don't need you to do that. Okay, so the second part of this is x plus 5 divided by 4 is greater than or equal to 2/3. So one way to do this is to multiply both sides by 4, and you end up with a fraction on the other side. And then you have to add and subtract fractions. The way I prefer to do it is to use cross multiplication because this is like a proportion. Two fractions with an equality symbol between them, I can multiply both sides by the denominator. So here I have 3 times x plus 5 is greater than or equal to 2 times the 4. Now all my fractions are gone. We multiplied 3 times the x plus 5, and we multiplied the 4 times the 2. Then I don't have to deal with fractions for the rest of the problem. And I get 3x plus 15 is greater than or equal to 8. Subtract 15. And 3x is greater than or equal to negative 7. Divide by 3. X is greater than or equal to negative 7/3. And this is in OR. Bring down the word. So when I put this on a number line, negative 7/3 is first, right? Negatives are always before positives. And 5/3 is second. And we have a closed circle less than 5/3 and a closed circle greater than negative 7/3. Is this one of those special cases? Yeah, it's all real numbers because the whole number line is shaded, and at the OR equations, we're looking for all the shading. Kylie? So the greater than or equal to and less than or equal to are closed circles. When it's greater than and less than, they are open. So when it's equal to, it's closed. So this is all real numbers as the final result. Okay? Let's see, 6, 5, 6, 7, 9. All right, so we have 6h plus 5 minus 14h is less than negative 11. And 5/9 h minus 1 is less than or equal to negative 11. So on the first equation, I'm going to combine like terms. So I get negative 8h plus 5 is less than negative 11. We're going to subtract 5. I get negative 8h is less than negative 16. Divide it by negative 8. What happens when I divide by a negative? It flips to greater than positive 2. Okay. And this is an and. And now this one we're going to add 1. I have 5/9 h is less than or equal to negative 10. Times by the reciprocal, 9/5. H is less than or equal to 5 goes into 10 2 times. Negative 2 times 9 is negative 18. Yes? Okay. As long as you make sure to multiply the negative 1 and the negative 11. So you should have had 5h minus 9 less than or equal to negative 99. Okay. Yes, that's okay. Okay, so I have negative 18, closed circle, less than, 2, open circle, greater than. This is an and, right? That means we're looking for overlap. What happens when there's no overlap and it's an and? It is no solution. Very good. 10. So we have negative 3a plus 5 is less than or equal to 7a, and 5.2 minus a is greater than or equal to negative 8.4. So we're going to solve each one separately. I have variables on both sides of the inequality. I like my inequalities with the variables on the left. So I'm going to go against my positive variable rule here. And I'm going to move my variables to the left. The problem here is that gives me negative 10a plus 5 is less than or equal to 0. Now, could you have done it the other way and added 3a? Absolutely. Okay. And it's actually shorter that way. Okay. So we're going to subtract 5, negative 10. A is less than or equal to negative 5. Divide by negative 10. And a is greater than or equal to, it has to flip because I'm dividing by a negative. You can't actually see that green. That's why I usually change it to pink and purple. What is 5 divided by 10? It is 1/2, right? 5 is smaller, so 5 divided into 10 pieces is not 2, it's 1/2, right? So be careful with that. I see that mistake made a lot. And then we're going to subtract 5.2. And we get negative a is greater than or equal to negative 13.6. And a is less than or equal to positive 13.6. We get that by dividing by negative 1. And so here we have, now this problem started as a decimal. You asked me, what should I change them so they're consistent? If we have one problem start as a decimal, then we should be using decimals for both of them. So we can make this 0.5. It's not a huge deal on a compound inequality to have a fraction and a decimal. You just can't have a fraction and a decimal in the same answer. Like, you can't have a decimal in a fraction. So this is 0.5, this is 13.6. Closed circle, greater than, closed circle, less than. So this is not one of those special cases. Bless you. Okay, here's number 11, fractions and decimals all together. So I prefer fraction buster when I have a problem like number 11 here. 1/3 x plus 3/4 is less than 5/6. I look for my least common denominator of 3, 4, and 6. What's the common multiple of 3, 4, and 6? 12, right? 24 is also a multiple, but it's not the smallest. We like to multiply by the smallest, less reducing in the end. So my LCD is 12. To do fraction buster, I'm going to multiply each term by 12 over 1. My goal is not to get them all to have the same denominator. My goal is to eliminate the denominators. Fraction buster, getting rid of the fractions. So here, 3 goes into 12 how many times? 4. And 4 times 1 is 4, so 4x. The next one, 3/4 times 12. 4 goes into 12 how many times? 3 times. 3 times 3 is 9. And 6 goes into 12 twice. 2 times 5 is 10. Now I have a really nice looking equation to solve. So we can multiply each term by the common denominator, and then we don't have to worry about getting a common denominator to add the fractions together or subtract them. And here I can subtract 9. 4x is less than 1. And then divide by 4. X is less than 1/4. Okay, this one we're going to get our variables together. We're going to subtract 4.9x. I get negative 4.8x minus 3 is greater than 1.8. We're going to add 3. Negative 4.8x is greater than 4.8. Divide by negative 4.8. And x is greater than negative 1. And this is or, right? It's important to write that word in between there. It makes a difference in how we read our thing. What did I do wrong? Oh, you're right. We have to change the sign. Thank you. To less than. Right? I divided by a negative. Yes. Or equal. Wait, what? Oh, on the paper it's equal to. There we go. Sorry. I copied it wrong. Okay. So x is less than or equal to negative 1. And x is less than 1/4. Well, this one's kind of weird, right? Closed circle at negative 1, shaded to the left. And at 1/4 I have an open circle, also shaded to the left. So you may have noticed that on the answer sheet it didn't write both of them, right? This is one of those cases where it turns around and they're going in the same direction. And it's an or. So it's all the shading we're interested in. Does x is less than negative 1 qualify as less than 1/4? Yeah, so all of the numbers that are less than or equal to negative 1 are also less than 1/4. So we don't need to write them both because the red shading here is all included in the blue shading. So our final answer is just that x is less than 1/4. And we want to recognize those cases, and it's important. That's one of the main reasons we draw it, so we can see if there's anything funky going on. Yes? So we don't need to write the x's less than or equal to negative 1 in our final answer, because all of those numbers are shaded here in red, right? They're already included in the statement that x is less than 1/4, because all of the numbers less than or equal to negative 1 are also less than 1/4. Mm-hmm. Okay, and number 12, right? Did we ask for 12?
Yeah.
Okay. Negative 4 less than 2x minus 4 over 5 less than 6. So this one, it's kind of like fraction buster. I only have one denominator, so I'm going to multiply everything by 5 to get rid of the denominator. Now in the middle, I'm not going to distribute the 5 and then divide by 5. I'm just going to cancel the 5 with the 5. If I multiply by 5 and then divide by 5, I get what I started with, right? So I end up with 2x minus 4 less than 30, and then negative 20 on the left. And then we can add 4, negative 16 less than 2x less than 34, divide by 2, negative 8 less than x less than 17. Nothing funky going on here. Open circles, shaded between. All right, so we're going to investigate a little bit of absolute value inequalities now. Remember that absolute value is a number's distance from 0. So when we have an equal sign, they need to be exactly that distance from 0. But inequalities are a range of numbers less than 3 away from 0, greater than 3 away from 0. So number 1, the absolute value of k is greater than or equal to 3. Take a second on your number line and draw 4 dots for numbers that are more than 3 away from 0. Put 4 dots on your paper that are more than 3 away from 0. They could also be exactly 3 away from 0 because it's greater than or equal to. Okay, so we want numbers more than 3 away from 0. Take a second and look at the person's number line next to you. Okay, do they have it correct? Did they pick numbers that are more than 3 away from 0, or did they make a mistake? Check each other out. How did they do? Okay, can you throw out some numbers that are more than 3 away from 0? 5. I heard 4. I heard 5. Negative 5. Negative 6. We say it's exactly right, more than or equal to, so I can put a dot at 3. And what are we seeing? We're seeing that it's everything greater than 3, right? And, not and, or less than negative 3, right? That's or. The numbers that are more than 3 away from 0 are greater than 3 or less than negative 3. It can't be both, so that's not an and, right? Can't be in both places. So how do we write this solution? X is less than or equal to negative 3, or x is greater than or equal to positive 3. Now the next one, number 2, the absolute value of k is greater than negative 4. Distances that are more than negative 4 from 0. You can't have a negative distance, right? Is a distance of 0 greater than negative 4? Yeah? Is a distance of 1 greater than negative 4? Okay, so 0 worked, 1, negative 1 worked. Distance of 3, is that more than negative 4? Yes. Same with negative 3. Whatever number I put in here, isn't anything I put in for k going to be bigger than negative 4? Because it's always going to be positive, and positives are always greater than negatives, right? So this is every number on the number line, which is all real numbers. So when we have the absolute value greater than a negative, it's all real numbers, because positives will always be bigger than negatives. What about values? Yes? Well, because if I plug in -9, the absolute value of -9 is going to be +9, which is bigger than -4. Right? If I plug in +200, the absolute value of +200 is greater than -4. It's always positive. Right? I could put -1,852, and the absolute value of that negative number will be greater than -4 because it comes out positive. Right? Now, number 3, the absolute value of k is less than 2. So I want numbers less than 2 away from 0. Put 3 dots on your number line for numbers less than 2 away from 0. 3 dots. Put 3 points on your number line for numbers less than 2 away from 0. Okay, share with your partner when you're done. You agree on your 3 dots? We should pretty much all have the same 3 dots if you're picking whole numbers, right? What are our 3 numbers? -1, 0, and 1. Now those are just our integers, right? Is -1.9 +1.99? Yes. So we have to put an open circle on the 2, and it's everything in between. How do we write that? -2 is less than all the x's, less than +2. Our less thans are our and inequalities. We want you to use between notation. Do not write them as separate inequalities. Questions so far? Can you think of any numbers? Oh, yeah.
How come it's, we put -2 is less than x?
Because it's the between statement.
So,
Remember that we take this side, it's x is greater than -2, right? But when we put it together, we have to turn it this way. So -2 is less than x, right? We have to turn it like that to put it together. Okay? And the between statement always has, oh, that doesn't, there we go, that's better. Our between statement always has 2 less thans. It means 2 is greater than x, and x is greater than -2, right? Our 2 is bigger than all the x's, and our -2 is smaller than all the x's. So it's between -2 and 2. Okay? It's inclusive when they're closed circles. It's exclusive when they're open circles. So it doesn't include the endpoints. Now can we find a number that we could plug into the absolute value of k that would give us a number less than -1? No. Because they always come out positive, right? So if I have the absolute value less than a negative, what's my solution? It's no solution. And my number line is empty. Okay. Okay, so our steps for writing absolute value are very similar to the equations and the inequalities. The first is isolate the absolute value. The second is if the absolute value is greater than. It's an or inequality. We saw that up here. Greater than for number 1 was less than the negative or greater than the positive. So let's write that because this is the number 1 place where people make mistakes. It's x is less than the negative number or x is greater than the positive number. Because it's going in opposite directions for an or, right? Greater than positive 3 and less than negative 3. Look at that number line for number 1 again. Okay. And if the absolute value is less than, we write the compound and, which is going to be the negative number less than or equal to x less than or equal to the positive number. Okay. We want the and notation, not separate inequalities for the less thans. Okay. And then we solve the compound sentence and adjust the final answer as appropriate. Be careful about special cases that result in no solution. Remember, no solution is the absolute value less than a negative. And all real numbers is the absolute value greater than a negative number. Those are our 2 special cases. Okay. All right, so number 5. I don't know why it's, it's number 5 because the first 4. The absolute value of m plus 5 minus 2 is greater than or equal to 7. So first we isolate the absolute value. How do we do that? Add 2. So the absolute value of m plus 5 is greater than or equal to 9. Now, some of you got points taken off on the quiz because you didn't write this step. Okay, don't do too much in your head. Make sure to write down the inequality and what it's greater than or less than, and then write your compound inequality. Okay, and so my compound greater than is and or. So we're going to write m plus 5 is greater than or equal to positive 9. Or m plus 5, I don't like that spacing, hold on. Stop it. M plus 5, what's the sign for the negative? Less than or equal to negative 9. Because to be more than 9 away, right? More than 9, I have to be greater than positive 9 and less than negative 9, right? Okay, so you need to be thinking about it in terms of that number line and what it means. So the less than the negative, greater than the positive for the ors. And then solve. Minus 5, m is less than or equal to negative 14, or m is greater than or equal to 4. Now, because we're using the same base equation, we don't end up having the sign flip on one and not the other. Because you're solving the same equation, just one with a negative and one with a positive number. So we don't kind of get those same direction inequalities. And that is negative 14 and 4 greater than or equal to 4, less than or equal to negative 4. These are the numbers that when I plug them into the absolute value m plus 5, I get answers greater than 9. Okay, questions? No, it does not matter which order you write them. I try to write the negative one just so it follows my number line, but it doesn't matter. All right, number 6, 4 times the absolute value of x minus 2 is less than 24. What do I do to isolate that absolute value? divide by 4. The absolute value of x minus 2 is less than 6. Okay, make sure you write that equation. Now, less than is and or. We determine that once the absolute value is by itself, too, because if that was a negative 4 and a negative 24, it would flip it. It's an and. So I'm going to write my between statement. What goes on the left? Negative 6 minus 2 less than 6. Okay. So we're going to write the between statement. For the less thans, we're going to write the two equations, opposite inequalities for the ors. And we're going to add 2. And I get negative 4 less than x less than 8. Draw it on a number line. Open circles, shaded between. All right, let's look at 7. The absolute value is less than a negative. Is that a special case? The absolute value is by itself, right? When is the absolute value less than a negative? Never. So what does that mean? No solution. Okay. Absolute value is never less than a negative. And when is the absolute value greater than a negative? Always. So what's our answer? All real numbers.